So in the last video, Dave talked about all the great things that semantics can do and when you might want to consider using it. It would be somewhat disingenuous for us to not present the counter-argument to that. When should you avoid using semantics? When you should absolutely consider maybe using some of the traditional technologies that we've already talked about. If you have a common and well-defined system, some of the ones that we've listed here, these are nuts that have already been cracked. There's out-of-the-box, commercial off-the-shelf software available. It works great, it's fast, it's easy to maintain in a lot of these cases, and it really accomplishes the task that's been set out. You probably don't want to go and invest a huge amount in learning semantic technology to go off and do an order entry system. I mean, there's so many of them out there and they really, really work well. You're far better off just going out and acquiring one that's already been done and getting the support that goes along with it. The other thing I would say is that this is not a silver bullet. It is not the technology that will end all other technologies. It can do a lot of really, really cool things. It addresses a lot of the problems that have not been addressed in the past by some of these more traditional technologies, but it can't do everything. If you have a transactional high-volume system, like claims processing or order entry, you're probably better off going with one of these systems that we already talked about and going out and acquiring one, because the nut's already been cracked, but also relational systems are really, really good at getting these transactional operations done and doing rollbacks and all of that great stuff that they're really good at. It's a problem that really addresses itself, or lends itself, I should say, to the relational systems. If you have homogeneous data, as opposed to heterogeneous data, which Dave discussed, you might not want to consider using semantics. If you have a really, really well-defined set of data that hasn't changed in years and isn't anticipated to be changing anytime soon, you lose a lot of the power of semantics and its flexible schema. You're better off just putting it into a relational database and having that rigid schema and all the benefits that go along with that when your data is well-defined. If you have a problem that's already been solved, you might not want to use a brand new technology for it. And this is really across the board, not just with semantics, but anytime you have a problem that's already been solved by smart people, you're better off standing on their shoulders and using their work that's already been accomplished, vetted, and proven out, tested, supported, all of those great things that come along with problems that have already been solved. You can really leverage a lot of great existing technology out there. Now, I talked about big data before, and now I'm talking about very large data stores, and that semantic may be a bad fit for those. And I want to clarify what I mean by that. If you have very large data stores in a legacy system, where you have decades of transactional records or financial records or things like that, where you have this very, very large set of data, I'm not suggesting that you couldn't use semantics to address that. But you might not want to. It might not be worth the effort of taking all that data, pulling it out and shoving it into a triple store when you have this perfectly workable relational database. You're far better off leveraging the power of federation when it comes to semantics, as opposed to taking that data and duplicating it into a triple store. So that's what I mean when I say very large data stores might be a bad fit. If you have an existing very large data store, you might want to look at federation as opposed to actual duplication of that data.